Okay, so this is the review for the test, Unit 2 test. In terms of formulas, you will get the arithmetic and geometric formulas for recursive and explicit. But what you don't get formula-wise is interest, exponential growth, and decay. So first question, consider the sequence 2, 10, 18, 26. Shay says that the formula for the sequence is a of n equals 8n plus 2. Marcus tells Shay that she's wrong because the formula for the sequence is a of n equals 8n minus 6. Who's correct? And then find a of 100. So they're actually giving you this formula not in explicit setup, but more in like the y equals mx plus b setup. That's actually should be enough to even tell you that we're looking for an arithmetic sequence. And the reason why we can kind of justify that is because from one term to the next, we're increasing by 8 each time. So if we use the explicit formula for the arithmetic sequence, in that to find any number, we need to start with the first number, which is 2, and then we need to do one less about however far we want to get of the common differences. And then the common differences here is 8, and that's what you're multiplying by. So this just needs to be transferred into y equals mx plus b. Essentially, all you need to do is distribute through the 8. So if I distribute in through this 8, we get for any number, we can start with 2 plus 8n minus 8. If we combine our like terms, a of n equals 8n minus 6. Remember, we combine like terms here, 2 minus 8. So this is the actual setup that Marcus had. So Marcus is correct. When we want to find a of 100, we can use Marcus's setup, or we can use the explicit rule. It doesn't matter which one. So I kind of want to show you that it really doesn't make a difference. If we use Marcus's setup, right, if we use this guy right here, a of n equals 8n minus 6. If we want to find the 100th term, then all we need to do is just multiply 8 times 100 minus 6. And then what we're going to get is 800 take away 6, or the 100th term equals 794. That's going to be a of 100. If you want to use the original setup that you guys had, the explicit formula, then you would do it this way. You would say, okay, the 100th term, a of 100, says I start with 2, but I need 99 more of those common differences. And that works as well. When you put this into your calculator, you end up getting a of 100 equals 2 plus, in this case, 792. And then you also get a of 100 equals 794. It doesn't matter which formula you use, the explicit formula or the one that was transferred into y equals mx plus b. Either is fine. Next one. Consider the sequence generated by the formula. A sub n equals 6n minus 4, starting with n is 1. So starting with the first term, generate the terms a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. Essentially, all you're doing is creating a table of values. And you're saying this is n, and this is a sub n. We want to know the first term, the second term, the third term, the fourth term, and the fifth term, the values for those. Well, the rules are it's 6 times n minus 4, 6 times n minus 4, 6 times n minus 4, all the way throughout. You'll probably see a pattern where you don't really need to do the math, but this is the first position, second, third, fourth, fifth, and when you do the math, 6 times 1 is 6, 6 minus 4 is 2. So the first term has a value of 2. The second one, 6 times 2 is 12, 12 minus 4 is 8. The second term has a value of 8. The third term, 6 times 3 is 18, 18 minus 4 is 14. The third term has a value of 14. Well, you should be able to see that the pattern is going up by 6s each time, and that should make sense because that's what your common difference is. That's your rate of change or your slope, assuming we were graphing this. So I could do all the other values or just realize that I'm going to go up another 6, and then I'm going to go up yet another 6. So that's what they're looking for, is what happens for the first, second, third, fourth, and fifth term, and it's 2, 8, 14, 20, and 26. The third, consider the sequence given by the formula a sub n equals a n minus 1 minus 5, where a equals 12. Well, this happens to be an arithmetic sequence, and the reason why we know that is because you are looking for the term before, the one they give you, and you're subtracting by 5 in terms of your common difference. So we know the common difference is 5. Or sorry, subtracting by 5, minus 5, and a sub 1 equals 12. So basically, if I start with my first number and I subtract by 5, there's my second term. And then I subtract by 5 again. There's my third. Subtract by 5, subtract by 5. So what happens is the numbers, the first 5 terms is 12, then 7, then 2, then negative 3, then negative 8. If we want to actually write the explicit formula, we can write this in two ways. We can basically piggyback off what they gave you in terms of the formula that was recursive, and you could say, all right, so for any number a sub n, as long as I start with my first value, which is 12, and I know I want to do one less of those common differences. And remember, you need that parentheses because you're multiplying by negative 5. You're not subtracting it. For those of you that like to actually turn it over into y equals mx plus b, what you're going to be saying is a sub n equals 12, and now as I distribute, I get minus 5n plus 5, or a sub n equals, in this case it's going to be, however you choose to write it, but 17 minus 5n, or maybe you say a sub n equals negative 5n plus 17. Either of those count as an explicit formula. The blue is in the way that they give it to you on the formula sheet, and the red is how you transfer that into like a y equals mx plus b. When you go to find a of 6 and a of 100, you should be able to use my blue or my red, and you're gonna get the same answer. Okay, so I'm going to use the red, and I'm going to say a of 6 is going to be negative 5 times 6 plus 17, which becomes, that should be a 17, which becomes negative 30 plus 17, or a of 6, my sixth term, ends up being negative 13. Again, you should have been able to plug that into blue and get the same thing. We still need to do a of 100. I'm going to put a of 100 into the blue. Okay, so a of 100 will go into blue, and then we'd say that the 100th term equals the first term, which is 12, plus 100 minus 1, or 99, more of those common differences, which happens to be negative 5. The final answer in this, again, I'm using my calculator, so feel free to have yours out as well. It ends up being negative 483. Once again, it doesn't matter whether you use the explicit formula from blue or the explicit formula from red. You're going to get the correct answer either way. Okay. So next question, determine if the following is arithmetic or geometric and write the formula for each. So what happens on this one? It looks as if I am subtracting by 3 each time. So I'm going to be arithmetic. If you use the formula that is given to you from the front of the sheet, you're going to say then for any number a sub n, I start out with 14, and I need one less of the common differences, which happens to be negative 3. Make sure you put this thing in parentheses. If you're choosing to go through and make it y equals mx plus b, and you're distributing your negative 3, you're going to get, in this case, a of n equals, when you distribute your negative 3, you're going to get 14 minus 3n plus 3, which ends up being 17 minus 3n. Either one of those are fine. On B, hopefully you see that you're multiplying by 5 each time, which means you happen to be geometric. So if I take a look at that formula on the front page, or remember how to do geometrics, I know that for any number that I want to start out with a of n, as long as I have my first value, my common ratio is multiplying by 5. And how many of those 5s do I need? Well, one less than I started with in terms of the value I'm going out. That's where your exponent is n minus 1. So take a look at the next one. It's 0.5, 1.5, and then it becomes 2.5, 3.5. So what's happening here is essentially I'm just adding by 1 each time. So if I'm adding by 1 each time, right, because 1/2 plus 1 is 3/2, 3/2 plus 1, remember, but I'm saying by adding by 1, you're adding by 2 wholes, right, because 1 equals 2 wholes, or 2, sorry, 1 equals 2 halves. So you're adding by 2 halves each time, which is the same thing, just adding by 1. So this becomes arithmetic. Spell that right. And what happens here is we say that for any number that I want to get out to in this particular series, I'm starting with a half. And then what I need to do is find one less of those common differences, which happens to be multiplying by 1. In this case, if I want to transfer this over and make this look like it's more y equals mx plus b, and I distribute my 1 through, then you basically are getting, in this case, a of 1 equals 1/2 plus 1n minus 1, or a of n ends up being negative 1/2 minus 1n. Either one of those works. Then all you've done to get from the blue to the red on part A and part C is distribute in what you're multiplying through n minus 1, and then combine like terms. Consider the arithmetic sequence. So they're telling you it's arithmetic. 13, 24, 35, dot, dot, dot. Hopefully you realize that you keep increasing by 11 each time. So write an explicit formula. Either way you can write it. If I write it this way, that for any value that I want, for any nth term, as long as I start with 13, I need one less of those common differences, of those 11s. Or I can distribute through. This one I'll actually show you the distributing part. So a of n equals 13 plus 11n minus 11, or a of n equals 2 plus 11n. Again, either one of those is fine. So when you're looking for the 40th term, I'll do this one both ways also. If I'm looking for the 40th term, I've got 13 plus 39 more of the 11s. Hopefully you guys have your calculator out in front of you. And this answer is going to get you 442. If I do it with the red, I say, okay, if I want to go out 40 terms, it's 2 plus 11 times 40. And again, the 40th value is still going to give you 442. Whatever you're more comfortable with, blue or red is fine. To find what the nth term is, or the value of n for the term that is 299, you just work backwards. And essentially, you're going to have to work backwards from red. Okay, we'll set it up in the blue, and then we'll go for the red. I think that's probably what you're more familiar with, but you end up really doing what's in red anyway. So what we're saying is, we know that the formula is a sub n equals 13 plus n minus 1 times 11. That's your common difference. Well, 299 is the value. 13, I'm going to distribute, plus 11n minus 11, or 299 equals 2 plus 11n. That's exactly what we had gotten in red. Subtract 2 from both sides. 297 equals 11n. Divide out by 11. N equals 27. So basically, 299 is the 27th term. just, I guess, the idea is in terms of the explicit formula, by starting out in blue, which we did, we ended up getting into 2n plus 11. And 2n plus 11 is exactly what we had here in red. So it's just to kind of say that maybe it was quicker, just instead of doing the first two lines of blue, to come up here in red and say, okay, well, 299 is my value of 2 plus 11n, solve for n. I just think it's a little bit quicker going from that route. Okay. And then we move on and we say, find the common ratio, explicit formula, an A of 20 for this particular sequence, 4, 12, 36, 108. You can probably see right off the bat it's not arithmetic. So how do you get from one term to the next? And hopefully you realize that you're multiplying by 3. So what happens here is your common ratio is 3. Your starting term, A of 1, is 4. So the common ratio, I guess that will be right here. Your explicit formula says, okay, well, for any term that I want to get to, I'm starting with the number 4. I've got the common ratio of 3, and I need one less of those common ratios than I do of the term I want to get to. So that becomes your explicit formula. And then to get out 20 places, I take my first term, and then I take 3 to the power of 19 because I need 19 more of those common ratios. This comes out to be a very big number, and it comes out to be 4, 6, 4, 9, 0, 4, 5, 8, 6, 8, comma, comma, comma. Okay, so 4,649,045,868. Again, good thing for our calculators. Kyra's been babysitting since 6th grade. She has saved $1,000 and wants to open up an account at the bank so that she will earn interest on her savings. Simple Bank, excuse me, Simple Bank pays simple interest at a rate of 10%. Simple interest. How much money will Kyra have after 1 year? Assuming she doesn't add any money into her account, how much money will she have after 5 years? So let's find out what the actual interest is, just the interest. So interest equals the principal amount, what you start with, times the rate that you get, your decimal, your percent as a decimal, times the time you keep it in the bank. So for Kyra, her interest that she's going to make is the $1,000 she starts out with. Her 10% of simple interest, remember, is 0.10. So 0.10, and we're talking about after 1 year. So the interest that she makes after 1 year is just $100. So then what happens is after 1 year, so the total amount that Kyra is going to have is her $1,000 plus her $100 interest, or 1 year is going to be $1,100. This is 1 year. I'll put A of 1. If we're dealing with 5 years, and remember it's just simple interest, we can think about the amount looking like this. If it's 5 years, we can say that the amount is going to be essentially what she starts out with, her principal, plus $100 per year after that. So we know that her amount was the $1,000 that she put in her bank plus the $100 simple interest she gets per year times 5, or after 5 years, Kyra's going to have $1,500 in her bank. Jack has $500 to invest. The bank offers him 6% compounded annually, so it's compound interest. How much money will Jack have after 1 year, 2 years, 5 years, 10 years? Where necessary, we're going to round to the nearest penny. So this basically says the total amount that Jack has in the bank after T time is the principal amount times 1 plus his rate to the year of T. So we know that what's happening here is we've got 6% compounded annually, which happens to be 0.06. So we can say after 1 year, we've got the $500 times 1 plus 0.06 to the 1, and this comes out to be $530. When we go for the second year, after 2 years, we still have the $500. We get a full percent of that plus 0.06 to the year 2. This one comes out to be $561.80. If we go for 5 years, we've got 501 plus 0.06 to the 5. This comes out to be $669.12. And then if we keep that in the bank for 10 years, it's 500. Well, that's fine. 1 plus 0.06 to the 10. And this comes out to be $895.42. Okay. You can do all this on your calculator. I don't know. I feel like we showed this to you, but I'm not really sure. So let me just kind of show you something. If you know the general formula, you don't have to keep plugging it in every single time. You can just plug it right into your calculator. So let me show you how this would work. Just going to clear the RAM. So second memory, 7, enter 2. So we should be able to go into y equals, and we should be able to say, all right, so for this particular formula, we know that Jack has $500 to begin with, and we know that he's going to do 1 plus 0.06, right, because we're ignoring this thing compounded annually, to the power of x, and we're calling it t, but x is the same thing. If we go to our table of values, second table, we should see that after year 0, he's got the $500. Well, we knew that. That's what he started with. But after 1 year, there's his $530. After 2 years, here's his $561.80. After 3 years, here is, oh, not 3, we're supposed to go to 5, sorry. But that was after 3. After 5 years, here's his $669. Now it says 0.11 actually up here, but if you plugged it into your calculator, you would get this part of your decimal, 112. So that should actually be 11 cents. I wonder why I got 12. I have to go back and look at that. So that probably will change that. And then if you go down to your 10th year, let me erase this. And in the 10th year, we've got 0.42, and that's rounded correctly. So I have to change that one value. All right, so you could always do it that way as well, as opposed to plugging it in onto the calculator. You can plug the formula in, and then you can take a look. So let's change this. This should be actually 0.11, not 0.12. 11 cents. Okay. Let's take a look at the next one. If you've got $200 to invest for 10 years, would you rather invest your money in a bank that pays 7% simple interest or a bank that pays 5% compound interest? And why? Well, let's compare the two. We know that if we're dealing with simple interest, we know that we've got interest equals the $200 that we start out with our 7% rate, and then after 1 year, it turns out that the interest that we're going to make here is going to be a total of, okay, so we want this for actually, so for the 10 years that we have this in, the interest that we're going to make, right, the $200, 7% for the 10 years, the interest that we're going to make is going to end up being $140. But the idea is that we're keeping everything in the bank. So the amount that we have is going to be the $200 that we started with, plus the $140 that we got in interest over the 10-year period, and we're looking for a total amount of $340. If we decide to go to the other bank where they do the interest compounded annually, then that becomes the total amount is going to be the $200 that we started out with, and then 1 plus the interest rate, in this case 5%, 0.05 to 10 years. As we get this on the calculator, the amount that comes out is going to be $325.78. So now, assuming that we're keeping it in the bank for 10 years, what would be the better bank to actually use? And it'd be the one that has the simple interest. So Bank A would give you more money. You would have more money in the bank, we should say, with Bank A after 10 years. Would give you more money after 10 years. Okay, so here it makes more sense to go with the simple interest. Eventually, over time, the compound interest is the one that seems to kind of take off, and you end up making more the longer you keep it in if it's compounds. Okay, a youth group has a yard sale to raise money for charity. The group earns $800 but decides to put its money in the bank. Calculate the amount of money the group will have if Bank A pays simple interest at 4% and they keep it in the bank for 3 years. So the idea here is we know that the amount is going to be the principal amount plus the interest that they make on that principal amount for the time that they keep it in. So we're saying that we've got $800 that we're starting with, plus now it's the $800 at the interest rate of 0.04 for the 3 years. So by putting it in Bank A for 3 years, the amount that we have is going to be a total of $896. Bank B is compound interest. It's compound interest 3% for 5 years. So Bank B, the total amount that we have is going to be the $800 that we start with, and it's times 1 plus the 3% interest rate after 5 years. With the calculator, what ends up happening here is now you have $927.42. So it looks like we're going to get more money if we keep it in Bank B. But in Bank B, we're also keeping it in there for 5 years. So if the youth group needs the money quickly, which is a better choice? So money quickly makes me think that maybe let's see what happens for Bank B at 3 years. So if we want to maybe just leave it in for 3 years, not 5, let's try Bank B at 3 years. So if we try Bank B at 3 years, we'll get 800 plus 1.03 after 3 years. And after 3 years, this bank is going to have $874.18. So if I'm going to look at Bank B and Bank A for the same amount of time, right? So Bank A, you get $896 after 3 years. Bank B, you get $874.18 after 3 years. If they want the money quickly, I'm going to say they should be going for Bank A, because in that case, they're going to make more money in 3 years than they will at Bank B. So they should choose Bank A because in 3 years, Bank A has $896, and in 3 years, Bank B has $874.18. So assuming they want it more quickly, in my opinion, that means 3 years to 3 years, they're going to go for Bank A because in 3 years they're going to have more money. If they can wait for 5 years, fine, then you go to Bank B. But if you want 3 years, there you go. Okay. A rare coin appreciates at a rate of 5.2% a year. If the initial value of the coin is $500, after how many years will its value cross the $3,000 mark? Show the formula that will model the value of the coin after 2 years. And this is something that we definitely want to get onto the calculator for. So what happens here is we know that the formula is going to be the amount is going to be the principal 1 plus the appreciation rate with the time. So that means the amount is going to be this coin, which is $500, 1 plus 0.052 after t years. So that's the formula that you're going to basically be using, and we're trying to find out when is the amount going to cross over the $3,000 mark. 1 plus 0.052 to the t. So you're going to have to use your calculator on this, or just start plugging in some random years. But I think the calculator is going to be the best bet. So here's what's happening. Go back to your calculator. Go back to y equals. Clear out what you have in there. And we're going to put on the formula that we just did. And we're saying that this coin, which starts out at $500, it appreciates. It gains value at 1 plus 0.052 to the power of t, to the power of x. If we go to our table of values, I'm going to go back to year 0. So year 0, the coin is worth $500. After the first year, it's worth $526. And in the second year, it's $553, and then $582. The idea is we want to find out, when is it going to cross the 3,000 mark? Well, we can just scroll down until we see where the coin first crosses the $3,000 mark. Right now we're at $2,080. We're now at $2,900. Here we go. We're now at $3,101.25, if you will. So in the 35th year, it was just at $2,948. But in the 36th year, it crossed the $3,000 mark, right? Because X is the number of years and Y is the value of the coin. So what's happened here is we can say, so after how many years? Well, it's going to be after 36 years. And the way that we did that is we went right to the calculator. Okay. The next one, 2 music rental companies have different penalty policies for returning a guitar that's late. Company 1, on day 1, the penalty is $5. On day 2, the penalty is $10. On day 3, the penalty is $15. On day 4 and 20, and so on. It's arithmetic, increasing by $5 each particular day. Company 2, on day 1, the penalty is a penny. On day 2, the penalty is 2 cents. On day 3, it ends up being, this should actually be 4 cents. So this should really be 4 cents. And this should really be, on day 4, the penalty is 8 cents, and so on. So the idea of what's happening here is we're doubling. So there's a typo. We got to fix that. So day 1 is a penny, day 2 is 2, day 3 is 4, day 4 is 8. And so I'm doubling each amount for every additional day that it's late. Jim rents a guitar from Company 2 because he thought it had a better late return policy. The tour he was playing using the guitar, where he used the guitar, lasted longer than he expected, but didn't concern him because the late penalty seemed so reasonable for Company 2. When he returned the guitar 15 days late, he was shocked by the penalty fee. What did he pay? And what would he have paid if he used Company 1 instead? So the idea is that we just need to kind of fill out this chart, and we can say for the company, for the penalty on Company 1, it's $5 a day. So we've got $5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, $75. So the explicit rule, what's happening here is basically for every day late, it says that we start out with $5 plus $5 each additional day. Or if you want to distribute this through, 5 plus 5n minus 5 really just says that every day you're late, it's just 5 times the day that you're late. On Company 2, this is starting out with a penny. So it's 1 penny, doubles to 2, doubles to 4, doubles to 8, doubles to 16, to 32. This seems reasonable so far. 64, $1.28, $2.56, $5.12, $10.24, $20.48, $40.96, $81.92, and then $163.84. So this is by doubling each time. And doubling, we know, is going to be geometric, where we're going to say to get the value, it's going to be 1 penny. We're going to double it, multiply it by 2 for each additional day that it's late. Well, take a look at what's happening here. When you compare the 15-day late charge, $75 company 1, $163.84 company 2. That's pretty crazy. So if we go back to what's happening here, it says when he returned the guitar 15 days late, what did he pay and what would he have paid for company 1? So company 2, the late fee was $163.84, and then company 1, the late fee would have only been $75. Interesting. So that penny a day that's being doubled ends up being a lot more than what happens if you just kind of take something and just add it by 5 each time. Okay, we're getting to the end. Mark just bought a new car for $15,000. As he drove it off the lot, his best friend Will told him that it would continue to depreciate 15% of its current value each year. If the car's value is now $12,750, according to Will, that's now. Remember, you bought it for $15,000, but once he drove off the lot, this now becomes his initial value once it's off the lot. What will the value be after 5 years? So we know that the value of the car is going to be what it's worth now, and then it's going to be 1 minus the rate that it loses over time. So even though he bought it for $15,000, once he drove it off the lot, he's now starting with the value from $12,750, 1 minus 0.15 to the 5th year. And the total amount of the car, according to Will, after 5 years, that car is only going to be worth $5,567.24. Kelly's mom takes a 400 milligram dose of ibuprofen. Each hour, the amount of ibuprofen in her system decreases by about 29%. How much ibuprofen is left in her system after 6 hours? And we're dealing per hour, so that's good. So what happens here is going to be the amount left in her system is what she starts out with, and it's going to be that minus 0.29 for 6 hours. And then the amount of ibuprofen left in her body after 6 hours is 51 milligrams. On January 1st, 1934, George Orwell deposited $30 in a bank that paid 4% interest compounded annually. How much money was in the account on January 1st, 1984? So that's a time period of 50 years. So what's happening here is the amount that's left in his bank is the $30 he started out with, 1 plus the 4% compounded annually to the 50th year, and this ends up being $213.20. And now what's happening here is find the equation or find the rule. Notice how we've got the terms are not going up in order. They're kind of skipping some values, right? So this was 7, this is 10. The 4th term is 16, the 6th term is 22. So the idea is from here to here, we're increasing by 3. If we were to do that again, increase by 3, that would be 13, which makes that make sense, increase by 3. That would be up by 19. So it looks like we're increasing by 3 each time. So we could do this a couple of ways. Remember, one of the ways that we did it is we said, if I'm increasing by 3, I know that 3 times all these term places is the beginning of my rule. And that's enough to really stop here. But make sure this makes sense. 3 times 1 is 3, plus 4 is 7. 3 times 2 is 6, plus 4 is 10. 3 times 3 is 9, plus 4, and so on. Okay, so long video for sure. Hopefully you will be good for the test. Good luck.